This is Chapter 1, Lesson 3, Rates. The main essential question that we've been asking this chapter is, how do you use equivalent rates in the real world? Okay, the lesson essential question are, how are rates and ratios related? We'll be able to answer that question almost immediately. Okay, as a startup, I want you to use your glossary, which starts on page GL1, to complete the definitions of the vocabulary words in the table. Okay, that I expect you to do on your own, but let me see if I can get it to work out for you. Okay, so this is all filled out for us, all right? I would expect you to do this on your own by looking it up in your book, but I'm going to go ahead and fill this out for you so at least you have the answers, but I would expect you to do this on your own. All right, a fraction is a number that represents a part of a whole or a part of a set, such as 1/2, 3/4, 9/12, 45/3, okay? A comparison of ratio is a comparison of two quantities by division. 2 out of 3, 2 to 3, 2 to 3, 2 over 3, okay? That's the examples. A rate is a ratio comparing two quantities with different kinds of units. Okay, they already asked, the last essential question is, how are rates and ratios similar? A rate is a ratio. It's just that it's with two quantities of different kinds of units, okay? Like over here, you have miles over hours, 36 miles over 3 hours, 36 miles for every 3 hours, $26 for 5 bags, 19 songs in 5 minutes. It is two quantities with different types of units, okay? Unit rate, a rate that is simplified so that it has a denominator of 1, such as 12 miles in 1 hour, or 12 miles per hour, $5.20 for 1 bag, 3.8 songs in 1 minute, okay? Nothing big, nothing hard, but that's the difference between them all, okay? We've already answered the lesson essential question, right? Okay, this I'd like you to try to do on your own. Go ahead and take a few seconds, pause the video, and try to do this. Okay, it says Desiree typed a 15-character text message in 5 seconds. Write a rate Desiree typed as a fraction. How many characters? 15. Okay, how many seconds? 5. What operation would you use to write the fraction in simplest form? Well, of course, we would use what? Division, right? We would find the least common, the greatest common factor between the two. Greatest common factor. We know that 5 is already in prime. Take 15, and that's 3 times 5, right? You circle the two numbers they got in common. Cover one of them up so you're not seeing it. Whatever that number is, divide by 5. So we're going to divide both of these by 5. We come up with 3 characters in 1 second. Okay. Now, so what did we use to write the fraction in simplest form? Division. Okay. Find a unit rate. A rate is a ratio comparing two quantities of different kinds of units. We already defined that. A unit rate has a denominator of 1 when the rate is written as a fraction. To write a rate as a unit rate, divide the numerator and the denominator by the rate of the rate by the denominator, okay? Which means this. They have a ratio of 15 to 1, a rate of 15 characters in 5 seconds. All right, we got to divide everything by 5, and we find out that is 3 characters in 1 second. That's a unit rate, okay? Here's an example. Here's one example, okay? Samantha picked 45 oranges in 5 minutes. Write this rate as a unit rate. We write the rate as a fraction first. We want to put oranges to minutes. Remember, it asks oranges in minutes, right? Okay, you compare the number of oranges to the number of minutes, then divide. 45 oranges in 5 minutes. To get this down to 1 minute, you want to divide everything by 5, and you get down to 9 oranges in 1 minute. All right, so the unit rate is 9 oranges in 1 minute, or 9 oranges per minute. Okay, the next example, okay, it's a little more tricky. Okay, I need you to follow along and pay very close attention to this one. This one is tricky. Here, let me write tricky. Okay, please pay attention. The Australian dragonfly can travel 18 miles in 3 minutes. How far can the dragon travel in 1 minute? All right, They first write the rate as a fraction, 18 miles in 30 minutes. They compare the distance to the number of minutes, then divide. Okay, that's not exactly what they did here. What they first did is they found the greatest common factor between 18 and 30. They find out that it's 6, all right? They divide everything by 6. They get it down to 3 miles in 5 minutes. Now, the ratio 3 to 5 cannot be simplified to a whole number rate. Remember, they're trying, you can write a, let me not say that exactly. Eventually, you can see where you can write a fraction on top of another whole number or fraction, okay? But right now, what they're trying to do is we recognize as math students that fraction is an unsolved or unfinished division problem, right? You know, it's like 1/2, you know, is 1 divided by 2, okay? So what we need to do is, since 3 miles in 5 minutes cannot be reduced properly, what we do is we just go ahead and we can divide everything by 5, right? So if we divide this by 5, divide this by 5, all right? We're not going to actually finish this division of the miles, okay? We've done this one. This is miles, and we're down to 1 minute, okay? 3/5 a mile in 1 minute. That's a crazy looking fraction. I know. Hold on just a second. They call a fraction like that a complex fraction. Let's not worry about what it is, okay? I just want to give you a name for it. All right? So it's 3/5 a mile in 1 minute. So the ratio of 3 to 5 cannot be simplified to a whole number rate. It can be written as 3 miles in 5 minutes, or as a unit rate of 3/5 of a mile to 1 minute. That's exactly what I did here, right? You saw how I solved that. All right? You need to be able to do that. Okay? So that means the dragonfly can travel 3/5 of a mile in 1 minute. All right. Very good. I hope you understood that, because there's going to be stuff like that. Okay. Let's do these problems. Emma downloaded 35 songs in 5 minutes. How many songs did she download per minute? Okay, so we're looking for 35 songs. Oops, not ongs. 35 songs. Let's erase it completely. 35 songs in 5 minutes. Okay, we're trying to get minutes down to 1, because you're always trying to get the time down to 1. Okay, if there's a time, you're trying to get the time down to 1, but that's not always true, right? The next question will show you that that's not always true. You're trying to get the bottom, the denominator, down to 1. So we're going to divide by 5. Now that equals 7 songs in 1 minute. Okay, so she's downing 7 songs in 1 minute, which is actually pretty fast. If you download songs, you know that that's actually pretty good speed. Okay. Jonathan is baking several loaves of bread to sell in his bakery. He uses 9 cups of water and 12 cups of whole wheat flour. How much water was used per cup of flour? Okay, so they want to know water to flour. So 9 cups of water to 12 cups of flour. Okay, I would look at this and be like, okay, the easiest number that I can pull out of the greatest common factor between those two numbers is 3. But if you need to do the work, greatest common factor, right? There's nothing wrong with showing the work. 9 is broken down to 3 times 3, and 12 is broken down to 2 times 6, which is then broken down to 2 times 3. They each share a 3. Okay, I'd stop looking at the 12, look at the 9, so you can divide a 3 out of both of them. You divide a 3 out of both. Okay, and now you got 3 over 4, right? Let me write this out a little bit better. So let me write this over here. 3 cups of H2O to 4 cups of flour. Okay, now what we're going to do is I'm going to try to get flour down to 1. Okay, so I do that by dividing by 4 on both sides. Okay, and then I get 3/4 cups over 3/4 cups of water, H2O, okay, over 1 cup of flour. Okay? Remember, that was just like, that's that tricky one. Okay? So now you can theoretically, you could stop right here. Okay? It's not going to change. You notice this didn't change. And here, let me go back a slide and you'll notice that, look, this didn't change either. Okay, look, it didn't change right here. They divided it down, they got it down to this, and this didn't really change. I just wanted to show you that there's no change. Okay, once you pull out the greatest common factor, you can just take those numbers. Okay? All right. Very good. All right. Example. An adult heart beats about 2,100 times every 30 minutes. A baby's heart beats about 2,600 times every 20 minutes. How many more beats does a baby's heart beat in 60 minutes than an adult's heart? Okay? All right. So the way that this is going to be done is through multiplication. Okay, step 1. Got to write it as unit rates. Okay? Now, that's great. See what they did is they put the adults 2,100 beats per 30 minutes, and then they simplified it by dividing both of them by 30, and they got it down to 70 beats per 1 minute. They did the same thing with the babies. They figured out that 2,600 beats per 20 minutes is actually 130 beats per minute. Then we got to get these up to 60 minutes because they're asking for 60 minutes, right? They want to know what each of them are in 60 minutes. So you multiply 70 by 60 and 130 by 60. And you get this difference. You got these numbers right here. 4,200 beats for adults and 7,800 beats for babies. Then you find the difference, right? You just do a little subtraction. Then all of a sudden you figure out that a baby's heart beats 3,600 times, more times in 60 minutes than an adult. Not too hard, right? It's very easy. All right, let's try this one. Go away. There we go. All right, let's give ourselves a little bit more room. A hummingbird's heart rate while resting is about 7,500 beats every 30 minutes. How many more beats does a hummingbird's heart beat in 60 minutes than a human baby's heart? Okay, we've got that information up here. Okay, a baby heartbeat is this. Okay, so we got to figure out what the hummingbird's heart rate is. So we need to take 7,500 over 30, 7,500 heartbeats. Spelled that wrong. Heartbeats. And this is 30 minutes. Right? Divide both of them by 30. And you get that, let me see, 75, so that's 250 heartbeats every 1 minute. Okay? Now we got to get this up to 60. So we got to multiply everything by 60. Now, if you were quick with it, you could probably notice that you could have probably just taken 7,500 over 30 minutes, multiplied both of them by 2, and got it up to 60 minutes, because that's what we really need, right? Is the 60 minutes. So, but I just wanted to go through the rate, gonna get down to unit rate. Okay, we need to multiply this by 60. All right, there's a 0. All right, I'm just gonna put that 0 there for running all these. Okay, I'll do the whole workout. All right, then you gotta annex a 0, and then you got 6 times 0 is 0. 6 times 5 is 30. 0 carry the 3. 6 times 2 is 12. Plus 3 is 15. Okay, and then you get 15,000 heartbeats in 60 minutes. All right, so we're at 15,000 heartbeats. I'm going to put HB in 60 mins, right? But the baby's heartbeat for every 60 minutes is 7,800. So we have 7,800 heartbeats. This is for hummingbird. This is for hummingbird. This is for a baby, human baby. And now we got to do a little subtraction, right, to figure out the difference, because they want to know the difference. So send the page a little bit. Scroll this back down so we can see our work. And we know that 15,000 is bigger than 7,800. And we do a little easy subtraction. Oh, it's not a 6, that becomes a 4. Okay. There's a 4. 0, that becomes a 14. All right. That is 2, and that's 7. 7,200 heartbeats. Okay, so the hummingbird heartbeats 7,200 more times in 60 minutes than a baby. Okay, that wasn't too difficult. And we had to do a little division, little multiplication, little subtraction, easy peasy. Okay, find a unit price. Okay, this is the same thing that we've been doing. It's just now with money. You know, you can use what you know about unit rates to find a unit price. The unit price is the cost per unit. To write a price as a unit price, divide the numerator and denominator by the rate. Divide the numerator and denominator of the rate by the denominator. Okay. So if they're $36 for 4 tickets, you divide by 4 to get it down to 1 ticket, and it'd be $9 a ticket. Okay. Here's an example. Okay. 4 potted plants cost $88. What is the price per plant? First, you write the rate as a fraction. Okay, $88 for 4 plants. You gotta divide by 4 to get it down to 1 plant, and you find out that each plant costs 22 bucks or 22 ducats. Okay, go ahead and start the guided practice. All right, and then the homework is the extra practice, page 37, 38, all. Thank you very much.